What if you could translate your thoughts directly into text without ever saying a word? Well, a new brain-computer interface is doing just that. It's decoding continuous language, non-invasively, straight from brain activity. So let's dive in and break down how this incredible technology actually works.
Okay, so check this out. On the left, you've got the words a person heard while they were in an fMRI scanner. And on the right, that's what a computer decoded just by analyzing their brain activity. Now, it's not a perfect word-for-word transcript, right? But look closer. It absolutely nails the core meaning, the emotional gist of the story. The essence is all there. And if you're thinking this is something out of a sci-fi movie, decades away, nope. This is real. This is a result from a scientific study that's already been published. This tech exists right now.
So, the big question is, how on earth is this even possible? We're about to get into the nitty-gritty of this non-invasive decoder and really understand how it turns the silent, raw data from our brains into actual, coherent language. Okay, so the first thing you have to wrap your head around is this massive scientific hurdle the researchers had to clear. It's called the slow signal problem, and it basically comes down to a fundamental mismatch between how fast we think and how fast the technology can measure those thoughts. It's kind of a paradox, really. fMRI technology is amazing at pinpointing where in the brain something's happening. But the signal it's actually reading, the flow of oxygenated blood, is super sluggish. It's kind of like trying to take a crystal clear photo of a lightning strike with a really old, slow camera. Just to give you a sense of how big this problem is, we speak at about 2 words every second. But the fMRI scanner, it only gets 1 picture of the brain every 2 seconds. So do the math. That means every single data point it captures is this blurry mashup of the brain's reaction to more than 20 different words all jumbled together.
So the real puzzle is, how in the world do you untangle that mess? How do you possibly pick out individual words when your signal is basically a 20-word smoothie of brain activity?
Well, the brilliant answer is you don't. Instead of getting bogged down trying to decode word by word, these researchers built this incredible AI system that sidesteps the problem. It focuses on decoding the overall meaning that's hidden in that blurry signal. And it uses this really cool 3-part approach. All right, part 1. They build what's called an encoding model. Let's just call it a personal tutor. This AI has one job and one job only: to learn one person's brain, inside and out. It figures out how to predict exactly how your specific brain will light up when it hears any word or phrase. It's basically learning your own unique brain language. And this isn't a quick process. We're talking about some serious training. To get this tutor up to speed, each person had to lie inside an fMRI machine for a whopping 16 hours, just listening to podcasts and stories. All of that data is what creates this super detailed, personalized map that links the meaning of words to that one person's brain pattern.
Okay, now this is where the magic really happens. First, you've got a language model, let's call it the storyteller, that just brainstorms thousands of possible sentences. Then, that personal tutor we just talked about steps in. It looks at each of those sentences and compares them to the actual brain activity that was recorded, giving each one a score based on how well it matches. And finally, a judge algorithm comes in, throws out all the low-scoring sentences, and refines the ones that look promising. This whole cycle, generate, score, select, just keeps repeating until it hones in on the most likely translation of what you were thinking.
So the big question is, does it actually work? Well, take a look at this. This table uses a metric called BERT score, which is just a fancy way of measuring how similar the meaning is between 2 sentences. And as you can see, the decoder score is way better than just random chance. Now, is it perfect? No, it's not quite at the level of, say, Google Translate yet. But for pulling meaning out of such a noisy, messy brain signal, this is a huge leap forward. Okay, but here's where things go from just incredible science to something truly mind-bending. Because this system isn't just decoding what someone is hearing, it's decoding what they're thinking. And get this, what's really wild is that the decoder was only ever trained on data from people listening to stories. That's it. But the researchers discovered it could decode totally different mental tasks. And that's the proof. It's not just interpreting sound processing in the brain, it's tapping into the brain's fundamental engine for meaning itself. Here's a perfect example. They asked someone to just imagine telling a story, totally silent, just inside their own head. And unbelievably, the decoder, which had never seen data from imagined speech before, was able to translate their thoughts. It captured the gist of their silent internal monologue.
And if you thought that was wild, it gets even crazier. Next, they tried to decode brain activity while someone was just watching a silent movie.
So the person is just watching this silent animated clip, right? No sound at all. And the decoder starts generating text that accurately describes what's happening on screen. It was translating a purely visual experience into language, just from their brainwaves.
Okay, so this is incredible, but it obviously brings up some really serious questions about mental privacy. I mean, if this technology exists, can our thoughts be read against our will?
Well, the good news, for now at least, is that your mind is pretty secure. The system has these 3 built-in safeguards that are actually really important. First, it's not a universal key. A decoder trained on my brain is basically useless on yours. Second, it needs all that cooperative training. Remember the 16 hours in the machine? You can't do that to someone without them knowing. And third, it only decodes what you're actively focusing on. In a way, your brain is its own password.
But okay, let's play devil's advocate. What if someone, a bad actor, has already trained a decoder on you? Could you actively block them from reading your thoughts?
It's a great question, and the researchers tested that exact scenario. And what they found was pretty amazing. When people were listening to a story but also actively doing some other simple mental task, look at that. The decoder's performance just tanked. You can consciously and very effectively jam the signal.
So how did they do it? What's the secret mental firewall? Well, it turns out it was ridiculously simple stuff. Things like just counting backwards by 7s in your head, or naming and imagining different animals, or even just telling a different story to yourself. Any of these simple mental tricks was enough to completely sabotage the decoder's output. So yeah, resistance is definitely not futile.
Look, we are standing right at the edge of a brand new frontier here. For the very first time, we have real proof that the meaning of our inner world can be translated into language. Now, the potential to help people who can't speak is just immense. It's incredible. But this technology also forces us, all of us, to confront a really fundamental question about our future. Who should ever have the right to listen in?